Okay, so talking about this project, calculator. First of all, in the program, you'll find these libraries as well as the packages. Now, these contain the definition of all the functions and all the statements which we are using in this VHDL program. Just like in C programming or C++, you have the header files. Here you have the library files. Then coming to the entity calculator. You can see here there is an entity by the name calculator, this block which I have selected. It has the information about inputs as well as the outputs. So these are the inputs you can see in keyword mentioned, which is telling you that these are the inputs. Below this you'll find the output, result 1, 7 segment and anodes. These are the three outputs. You can see out keyword mentioned, so it is telling us that these are the outputs. Then we have the standard logic. These are the data types. Standard logic vector. These are the data types. In all the programming languages, the data types are there, so the same meaning of these data types. The size of the vector is telling you that this is an 8-bit bus. In computer hardware we have buses. In the same way, this is the bus. Wherever the standard logic is mentioned, it means it is a single bit signal, or you can say port. But wherever the vector is mentioned, you'll find the size mentioned of the bus. So 7 down to 0 means 8 bits bus, and 6 down to 0, as it is mentioned in the 7 segment, it is a 7-bit bus. Above the port, you'll find the generic keyword and then N and M mentioned. These are the integers. Now the purpose of writing these M or N, or you can say any variable, is that inside the program you might have to write this number 65536 or 50 into 10 to the power 6 many times. So instead of writing it many times, we simply write the name of the generic given. So wherever the M is mentioned, the compiler will automatically know that this M means 65536. After that, you will find there is an architecture. This architecture tells you the behavior of the circuit, how the circuit is behaving, or you can say functionality of the circuit. So we can see that there are some signals created before writing the program, and some constants have been created. Now signals, you can say that these are the inbuilt wires which connect one block of the circuit to the other block. Here the constants start, compute, end. These are the three states of the finite state machine. You must have done the course on digital circuits or digital design. In that you must have studied about the finite state machines. So in those state machines we have the various states. So these are the three states which we have created here. After that, some more signals have been created. Now the purpose of each signal is, it's not mentioned here, but the purpose of the signal is that these are the inbuilt wires. Now after that, you'll see a function 2_BCD. The name is telling us that this function has been written to make a task in which whatever binary number you are sending it as an input, it will convert it into the BCD number. you must be knowing the difference between binary numbers and BCD numbers. So the purpose of this functional block of the function is that it will take in the 8-bit binary number as an input and it will convert it into a BCD number. So this whole block is telling that. There's a usage of loop. There is some other statements if condition is there. So depending on that, we implement this functionality. Anyways, that is not important at this moment. Talking about the main program, you can see that we have created a counter which is counting from 0 to n, which is counting the number of cycles basically, because we know that we are supposed to put this program on the basis 3 kit. So the frequency of the crystal available on the basis 3 kit has to be made use of. Then in this block of code, it is saying that if rising edge of the M clock, rising edge means the positive edge, or you can say the transition which is happening from 0 to 1, the counter is getting implemented, or you can say counter is getting incremented. And if the value of the counter is n by 15 minus 1, so the counter is resetting to 0. So simply what we are doing here is we are dividing a clock. That is the only purpose of this particular block. The main block starts here, where the main functionality begins. So you can see that initially the program is in start state, and depending on what the inputs are given, like if you see the first scenario, it says that if the subtraction signal is high, others are low, it is going to subtract. Similarly, if there is an addition signal, then it is going to add. So basically this particular block is telling you that depending on what condition the control is given to this section. So there is no functionality implemented in this case. It is simply sending to the next state. Now what is next state saying? That if the subtraction signal is high, then the input is given will be subtracted. If the add signal is 1, then addition will take place. If negation neg is 1, then complement of the signal is done, or the input is done. If C XOR is 1, that means XOR operation, so it is performing the XOR operation. If C OR is 1, it is doing the OR operation. If AND input is 1, then it is doing the AND operation, and so on. And finally, when the computation ends, the results are taken into the respective variables or the signals, and finally the program comes to end. There is a small counter being implemented separately, which is counting the number of pulses, and it is also giving you the output of the 7 segment, because calculations or the calculator is going to show the result on the FPGA, and FPGA planar board generally has the 7 segment displays. So this particular block is converting the data into the 7 segment display. So so earlier it was, in this case you can see the numbers are mentioned, which number is going to be represented. So all this block is going to concentrate on the implementation on the 7 segment display.